All right, good afternoon, folks. My name is Prashant Krishnappa. As you can see, my name is a mouthful, so everybody calls me PK, including my daughter and son. So you can call me PK. I'll be presenting the Troubleshooting Nexus 6000 and 5600 series switches today. I hope you're all in the right class. If you are, great. If you're not, even better. So a little bit about myself. I've been with Cisco for about 15 plus years. Out of the 15, I've spent about 13 in tech, taking cases on various products and technologies, including the Nexus 5Ks and the Fabric extenders. For the past 2 years, I've been with the business unit, which makes the N256K product, so basically the Nexus 2000s, 5000s, and the 6000s. And my primary job is to make your lives better, or at least make sure this product works as advertised. So I work as an escalation engineer, where I work with tech and the field teams to resolve issues which they're not able to. And since I'm part of the BU, I also have some leverage to make certain things happen. So I try hard to make the product a little better. I work on serviceability items, any enhancements, and also prioritizing bug fixes and documentation and so on. So it's quite possible that I might have worked with you directly or indirectly on if you have any Nexus 5K, 6K issues and which were escalated to the BU. Again, welcome, and hope you're all having fun at CiscoLive, and let's get this done and go to the Cisco Customer Appreciation Party. This is the kind of an agenda I have for today. This is primarily a troubleshooting session. I'm not going to be covering architecture. There are multiple architecture sessions at CiscoLive. I'll be covering some of the common issues which you can see in EO networks with the Nexus 5600 and 6000s, and hopefully you should be able to troubleshoot or at least get a head start if you ever have to open a tag case. And also I'm going to go over some of the tools, some of them which are quite popular like Ethernalyzer, and some of them which are new to the platform, such as ELAM, which you can use to troubleshoot your day-to-day problems in your network. Again, this is not a feature troubleshooting session, but we do have quite a few feature troubleshooting sessions as well at CiscoLive. These are some of my related sessions. Since here we are on Wednesday afternoon, most of these sessions have already happened, but the good thing is they're all online, or they will be online over the next few days. So you can catch up or watch them online when they become available, especially some of the feature ones like Fabric Path, VPC, and I highly recommend this one because this session goes over some of the cool data analytics we have with the Nexus 5600 and Nexus 6000s. One silver lining is we still have the architecture session, which will happen tomorrow morning. Has anybody signed up for this architecture session? I see a few hands, but I don't know how many spots are available. If you are interested to know the inner workings of the box, this will be a good session, and it's covered or presented by a technical marketing engineer who is pretty good with this platform. So if you are interested, you might want to see if they have any spots available. And this is the kind of an agenda I have for today. First, I'm going to talk briefly about the product and some Nexus commands which are not very common, because I do not want to overwhelm you with the platform issues to begin with. And then I'm going to go over some of the common issues, and including like MTS issues, crashes, CPU troubleshooting, and CRC errors, which is again kind of a little different, troubleshooting CRC errors with a cut-through switch. And then I'm going to cover forwarding, which is L2 unicast, L2 multicast, L3 unicast, and multicast. And then I'm going to cover buffering and queuing, which is a significant difference between the previous generation Nexus 5Ks and how to troubleshoot some queuing problems. And lastly, I'm going to cover ELAM, which is, I've saved the best for the last. How many of you in this room already have a Nexus 5K previous gen or a 6K 5600? Looks like almost everybody. So you're in the right class. So Nexus 5000 has been an immensely successful product for Cisco. We have about 18,000 plus customers, 30 million plus ports, and we launched the first product, 5010, 5020, in the 2008 timeframe. At that time, it was kind of a breakthrough product because we offered the end-of-the-row, top-of-the-rack solution, and also it was the first switch in the industry to support converged Ethernet or the unified fabric, so you could do FC, FCOE, and classical Ethernet. So in the 2010 timeframe, we launched the 5500, so basically it was the next generation. And we also added some new features such as layer 3 capability, because the previous gen was layer 2 only. So the 5500 supported layer 3 and also support for fabric path. And also it had some other changes like enhanced buffers, but layer 3 buffering and fabric path were the main support there. And the biggest change came in 2013 with the Nexus 6000s. We had two form factors, the 40 gig optimized 6004 and the 10 gig optimized 6001. So 6004 was a four slot, and the 6001 was a one rack unit. And then last year, and now in 2015, we rebranded the 6004 as a 5600, and we've been selling the 5600s. Again, we have like multiple form factors of the 5600s here. So I get asked this question a lot, like what's the difference between the 6000 and 5600? Not much. It's the same ASICs, same software base. The only difference is it has a newer spin of the ASIC which also supports VXLAN, which is the next new thing in the data centers today. Some of the use cases for this product, it's kind of useful to know where this product is deployed. The most common is the classic 3-tier, where you have your Nexus 7000s in your core, and you have your Nexus 5000, 6000s in your access/distribution in a VPC setup with lots of access. And I've seen some customers who use the Nexus 56, 96, and the 6004, which are the large form factors as their core as well. So it works fine even there. The other common thing is with the evolution of fabric path, we have a lot of customers use the 5600s and the 6000s in fabric path topologies. Again, here, some customers have Nexus 7Ks as spine, and I've seen quite a few customers use the 5696 and the 6004s as their spines as well. And the lower form factor, 5672s and 128s with VPC Plus in their access. And as I said, a unified fabric was one of the unique features we launched even at FCS, so we have enhanced that feature, and it's available in the 5600 and 6000s as well, and now even the MDS and the Nexus 7000s also support fiber channel over Ethernet. So we do have quite a few customers who deploy this platform with a converged fabric where they have classical Ethernet as well as fiber channel and FCOE across the network. And lastly, with the 5600s and VXLAN being the next new thing, we kind of anticipate more deployments with VXLAN and with the layer 3 and VXLAN as an overlay going forward as well. All right, so now let's get into some of the commands which are useful to troubleshoot and which you guys might not be very familiar with. The first one is the show CLI list. To be honest, I would not be able to do my job without this command because I, for one, cannot remember show commands or debug commands. So if I'm troubleshooting an issue, in the past, I would know that I've done a show command or a debug command, but I cannot remember it. And at many times, you cannot just question mark out of the command line because it might be a show system internal, it could be show platform, so it's kind of hard. So this is where the show CLI list comes into play. It's basically a repository of every show command and debug command we have in that particular Nexus OS. Here, for example, I'm trying to do a debug spanning tree, and I want a particular option, so I can just do a show CLI list and grep for it. And as we move along with my presentation, you'll see that some of the commands are not very intuitive, so this command will be very useful in finding those commands for troubleshooting your issues. The next thing, I'm sure a lot of people use this, but some people do not. In the Nexus 5K, 6K, or any Nexus platform, we support egrep, grep, and all the regular expressions. So if you're troubleshooting an issue and you want to keep your terminal output with only relevant data to the problem you might be having, you can exclude all the non-relevant fields. So here, say I have a switch with 500 interfaces, and I just want to see the Ethernet interface numbers, and say QoS discards on QoS group 2 or 0, I can exclude all other outputs and just see what I want to see on my terminal. I came from an iOS background. I'm sure a lot of you came from iOS background too. In iOS, typically if you had to debug a problem, you had to go and turn on a debug and wait for the problem to happen. But we all know like problems do not wait for us. They happen in the middle of the night, they happen over the weekend, and you cannot run a debug on a production network because it might have some impact. So this is where FSM comes into play or useful. So this is what I call as an always-on debug. So it runs in the background. You do not need to configure anything. And it stores what is called as event history. So we have this for almost every process in the switch. But the problem is you have to always keep in mind the event history buffers are not infinite, so you need to collect them sooner than later. So I'm going to go over a case study on how this can be useful. And also sometimes you'll have to compare timestamps, sometimes even across switches. So it's good to have a common NTP or common clock source across all your switches in your network. Here are some of the common processes, but like I said, we have event histories for almost every process. All right, here's a use case. Say we have port channel 12, which is this one-port VPC port channel. Say it flapped and came back up in 15 seconds. So far, we have that on April 18th at 8:06, the port channel went down, and in 15 seconds, it came back up. And this happened to be on a Saturday at 8 o'clock in the morning. Say you were in bed sleeping or you were at a party somewhere. And the server guy calls you or texts you and says, dude, my server went offline for 15 seconds. I think your network did something. I've been in this business for about 15 years, and I think everybody agrees that we are guilty unless we are proven otherwise, right? So now time to put out detective ads. Obviously, this is a problem which happened in the past, and I'll show you how event histories or finite state machine can help. Since an interface flapped, first thing which comes to my mind is perhaps I need to check for Ethernet port manager event history. Again, I don't expect people to remember this command, but you can use the show CLI list and figure out the command. So here, at the same time when the port channel flapped, EthPM says, I didn't do it. It said no flap requested. Again, sometimes the event histories are pretty intuitive, sometimes they're not, but nevertheless, they're still useful. But in this case, I think anybody can read this. Basically, it says no flap requested. Since it's an LACP port channel, the next thing I check for is the LACP event history. At the same time, I see something interesting. Can anybody guess what the problem could have been? Basically, it says PDU timed out. Correct. The answer is, in this case, the server stopped sending LACP PDUs. Again, I simulated this in my lab, so I have a server in my lab where I can start and stop LACP process. So I stopped LACP process, and by default, like LACP runs on PDUs, right? So if the switch does not hear a PDU for 3 times the hello PDU, which is 90 seconds, the port channel would have flapped. So then I turned on the LACP process. That's why the port channel came back up. So as you can see, again, this is for a simple case, but finite state machines or event histories are very powerful in troubleshooting an issue which happened in the past, and you do not have to wait for the problem to happen again, so you can take corrective action. So you could now call back your server guy and say, don't spoil my weekend. It's your turn now. All right, let's talk about some debugs. Since we have finite state machine and event histories, I personally typically do not run debugs, but there might be occasions where you have to run a debug. One good example is BPDU RX, because we do not have event history for BPDU RX. We do have event histories for other spanning tree stuff, but not for BPDU reception. So say I want to run a debug. Personally, I do not like to run debugs and let it scroll on my terminal because it's too busy. It cannot read them. Also, at times, you might lose your terminal control of your terminal session. So before I run a debug, I typically fire up a new file. Here I'm doing like a debug log file, CiscoLive debugs. When I do that, it creates a file called CiscoLive debugs in my log directory. And then I can run any debug I want. So here I'm trying to run debug for spanning tree BPDU RX for tree 10, which is VLAN 10. Again, any debug I run, I try to be very specific as possible because it's good to not have data which is not relevant. So then I can do an undebug all, and all my debugs would not scroll on my terminal. Instead, they would be in that file. You can look up this file on the switch itself, or you can also export it to your FTP server or TFTP server. Any questions so far? Again, we also have our question managers here, a bunch of buddies from TAG and escalation here. So I'm sure a lot of you know that we have this question manager concept with CiscoLive this year. So if you have any questions, feel free to use the question manager tool. I'll also be stopping and pausing and taking questions. I want to keep this interactive as far as possible. All right, the next thing I'm going to talk about is MTS, because I had an escalation on MTS issue recently, and I'm going to use that as a case study. Like any other Cisco platform or any other platform, we have like multiple processors running on the switch, and we have to have some kind of an IPC to communicate between processors, right? So this is where MTS comes into play. At a very high level, how IPC works is, say you have process A wants to talk to process B. They grab what is called as an MTS buffer, do their operation, and then release the buffer, and so that the next process can take the buffer and do other things. But when there are certain things happening in the event, some events happening in your network, like MTS message is coming too fast or through a software bug, you might have a deadlock condition where a buffer might not get released, and you might have problems, what we call as an MTS buffer problem. So the typical problems is, like you might have a high CPU, unresponsive command line. If you do a show run, you might get a message, something like service not responding, or you might not be able to configure certain interfaces. So again, like I said, I was involved in one such escalation recently. I'm going to use that as a case study because I was able to reproduce that in my lab. So this is when I was involved. So basically, a customer had upgraded a bunch of Nexus 5Ks from, I believe, from a 5.2 release to a 6.02 into 5 release. And after the upgrade, the switches worked fine for like a couple of days, and then they went to configure an interface, and they were getting this message. So basically, they were not able to shut down an interface. They were not able to bring up an interface, but any interfaces which were up were functioning fine. And then they reloaded effects, thinking it'll come back up, and the effects did not even come back up online. So whenever I see a message like this or a service not responding, the first things I check for on the switch is MTS. How you can check for that is you can do the show system internal MTS buffers, and that'll tell you the number of MTS buffers in use. In a good, healthy switch, typically this number is in single digits. I'm sure if you guys SSH to your switches, you might see this in like 4 or 5, and those 4 or 5 are typically expected because of your VTY sessions or console sessions. But 89 is definitely high because these things happen at milliseconds and microsecond time intervals. So then I started looking a little more. So here I see that SAP, which is like a process or a service access point, 175 is holding up 81 buffers, which is definitely not normal for this platform. So obviously then we start looking around a little more. Then I do the show system internal MTS buffers detail. Then I see that SAP 175 and SAP 181 and some opcodes. And also the important thing is the age column. So this age column, I think this, if you were to, this is in milliseconds. I did the math, and this translates to about 45 minutes. There's no reason why this buffer should be held or stuck for so long. So then I started looking up the SAPs and the opcodes, and then we found that each PM was deadlocked on each PC during a link down event, and obviously this doesn't mean much. So then we went back to the customer and looked around the switches because they were seeing this problem on multiple switches. And we found that the circumstances, how they upgraded the switches, and then we took the same process to our lab, and we found that there was a bug. And the root cause for this was a bug was getting triggered due to an ActiveX link flap during a VPC delay restore when the VPC delay restore timer was in effect. Again, this problem is not very common, but if you see a problem like this, unfortunately on the Nexus 5K, 6K, there's no clean way to get out of it, and reload is the only option. Any questions? All right, let's talk about platform crashes. Nexus 5K, 6K never crashes. Let's go on to the next section. Has anybody had a Nexus 5K, 6K crash? That's good, very few. All right, jokes aside, I think a lot of people know that Nexus 5K, 6K is a single supervisor system. So we do not have the luxury of having a dual supervisor in the system. So if a critical process were to crash, actually it makes sense for the switch to reboot, because if an FWM process crashes, we want the switch to reload and come back up rather than black hole traffic. But there are some restartable processes, like NTP was not restartable 2 years ago. If NTP were to crash, you would think, why is my switch reloading, right? Which makes sense. So now we made NTP a restartable process. Same thing with SNMPD. If SNMP were to crash a couple years ago, the entire switch would reboot. It does not happen today. So then the list keeps growing. So again, I work with engineering, like I said, to make your lives easier. So that's one of the primary things I have on their plate, is to make as many processes as possible as restartable. But today we still have quite a few processes which will crash the box if they were to crash. If a switch were to crash or a process were to crash, we typically log a syslog message. And we also write a core file. So basically it says core will be saved, and this core is basically a state of the process right before it crashed. So extracting the core file and getting it to TAC or Cisco would be critical to root cause your crash. And also, obviously, if a switch crashes, you'll get notified by either your application teams or your NMS teams, but you can do certain commands after the switch came up to figure out if it has had a crash. So here I do a show system reset reason, and I see a century hap reset. Again, this was an escalation I was involved recently, so I'm going to use this as a case study on how to troubleshoot or how to extract the relevant information for a crash scenario. Extracting the core file perhaps is the most important thing you need to do if a switch were to crash. So if you do a show course, you'll see if there was a core file written, and in this case it is, and you need some parameters to extract the core, like for example module number, instance number, and the process ID. And in this case the process name was Century. When I got this escalation I had no idea what Century was, but now I do. I'll tell you later. And this is what I want you guys to take from this section the most, because this is different compared to other Nexus platforms. Again, I'm trying to get this behavior change, but today it's not there. So the core gets saved to what is called the volatile section of the memory. So if the switch were to have another subsequent reboot, we lose this core file. So please, if you have a switch crash and if you want a root cause, try to extract the core before it were to go for another reboot. Copying the core is, again, not very complicated. You just do a copy core command, and you need certain parameters, and you get that from the show core command. And again, you can copy it to a remote server, or at the bare minimum, I suggest that it copy it to boot flash, which is persistent, so that even if the switch were to crash, you still have the core file saved. Also, when troubleshooting certain core files or crashes, show process log is useful because it also has like how much memory the process was holding before it crashed. So this command is also useful to get for root causing crashes. Again, like I said, I was involved with this escalation, so we had to ask all these questions to the customer, and we were able to figure out what happened and also try this in our lab and reproduce it, and now we have a fix for it. So I can ask yourself, like, why my switch crashed? Was I doing something? Did I do some Nexus OS upgrade? Did I configure something? Was there something changed in topology? So the more data we get from the customer, the better we are in a better position we are to give you a root cause and a fix. So at least in this case I was involved. Century process happens to be a process for 100 gig line card on the 6004s and the 5696. And this particular customer was upgrading their Nexus 6004 from a 6.0 release to 7.1 release. And they did the unsupported upgrade path, so the BIOS did not get upgraded. And this 100 gig LEM requires a particular version of BIOS. And they hot inserted a 100 gig LEM, so the switch crashed. Obviously, it should still not crash, but that's the bug here. But obviously, it was documented in the release notes. If they had the right BIOS, the switch would not have crashed. Any questions on this section? All right, now let's move on to like troubleshooting control plane issues and high CPU, and how to use Ethanalyzer, which is a built-in tool. Again, this is not an architecture session. If you're taking the architecture session, you'll see this slide for almost every form factor platform we have, but it's useful to know the architecture to understand and troubleshoot certain issues. So I'm going to cover this briefly. So under the hoods, this is how the architecture of any Nexus 5K, 6K looks like. And the number of port controllers, which basically are for your connections to the ports, that depend on the form factor, and also the number of fabric ASICs depends on the form factor. So this was for my 5696, so we have 4 fabric ASICs, and if all the line cards are fully populated, it have 32 UPCs. And we also have the supervisor, which sits on its own UPC, which is UPC 0. So if any control plane traffic, which has to go to the CPU, has to come into one of the UPCs, goes to the fabric, and enters the CPU. So if I were to zoom into the UPC 0, which has the CPU, this is how it looks like. In the back end, we have a quad-core 2 GHz CPU, which has like multiple NIC cards. Like internally, they're called E3, E4, and E0. Again, I'm going to talk more about what goes where, but I think common sense prevails. Like this is low priority traffic, high priority traffic, and this will be your management zero interface traffic. So this is our out of band. So this is one of the reasons why we always tell customers to manage switches using out of band, because it does not go through your in-band interfaces. And also you can use this command to get the mapping for the CPU ports to the ASIC. As I said, it's UPC 0. If you don't trust me, you can use this command. All right, let's talk about control plane policing. I think everybody knows what control plane policing is. It's been with Cisco products for quite some time. So basically, it's a feature we have in most Cisco platforms to protect the CPU from either malicious attacks or inadvertent attacks, like meaning you could have a server which went rogue and starts blasting ARP traffic, and we don't want that traffic to take down the switch or other protocols. So we have control plane policing like any other Cisco platform, but we do COP only for E3 and E4, so we do not do COP on E0. If I were to go back to my previous slide, there's no COP on this interface. There is only COP on E3 and E4. So one more reason why we always tell customers to have their management zero network on their own dedicated VLAN with not many devices in the management zero VLAN. The reason being, we do not want a /16 network with thousands of hosts on the management zero VLAN, right? So again, common sense. So COP is enabled by default, which is a good thing. You don't have to do anything. But to see if you're having any COP violations, you can do a show policy map interface control plane, the classical QoS-based command. And if you're seeing any violations, you'll see them increment here. But if I'm troubleshooting COP issues, I use this command more. Again, it's just a replica of what you saw in my previous slide, but I like the layout of this command because all my drop bytes are in one column. I don't have to grep and egrep to look for my drops. And also, this also has some more processes like SDP, which is Satellite Discovery Protocol, which is not part of our show policy map command. Again, you can use any, but personally, I like this. And also in the newer software versions, ShowTech has both the outputs. So we do what is called as a template-based COP in the Nexus 5K, 6K. You cannot have a switch without COP. So when you power up a switch, it comes up with the default COP policy. And it has its own CIRs and for different classes. And you can look up the config guide, or you can do the show policy map command to look at what the CIR is. But say you have a case where the default does not work for you. So we have multiple options here. So we have the scaled L2 and scaled L3. Again, as the name suggests, scaled L2 is more for customers who are doing heavy layer 2 multicast or layer 2 or like fabric path, because we have higher CIRs for some layer 2 protocols. And scale layer 3 is for customers who are using it in layer 3 topology. So we have higher CIRs for, say, ARP or ICMP or green traffic. Say none of them work for you. At that point, I would recommend that you investigate why it's not working, because our defaults in these templates work fine for majority of the customers. So maybe something needs to be checked in your network. But say the worst case, you have a scenario where nothing works, then we have this customized COP policy. So you can go with a customized COP policy. What it gives you is you can make up your own CIRs. But you got to be careful there because if you allow too much, you can take the CPU down. So that's why I said if you're going to go with customized, first make sure to see why any of the predefined other two templates are not working. Again, this question gets asked a lot. Can we attach my own class map to any of the templates? The answer is no. The Nexus 5K, 6K does not support it. And that's, again, this is actually a blessing in disguise. So you cannot remove a COP. I know some Nexus platforms, you can remove COP. On the Nexus 5K, 6K, you cannot remove COP. For example, say you have layer 3 applied. If you remove it, it defaults to policy default. Applying the configuration, it's pretty simple. You go to control plane config mode and apply the service policy input to whatever template you would like to. And again, no reload is required, so you can do this on the fly. Any questions so far? All right, we have COP to protect you from problems like high CPU, but you can still have high CPU because your management 0, for example, is not protected by COP. So when you're troubleshooting for high CPU, it's always good to have a baseline because otherwise, what are you going to compare against, right? So you might see 25% CPU one day and say my CPU is high, but what are you baselining against? So when you have a network in a good, healthy state, try to monitor for your CPU and have a baseline so that you can compare when you have something what is abnormal. And when troubleshooting high CPU issues, again, the typical Cisco commands work on the Nexus 5K, 6K as well. The show process CPU history, the SART, and the show system resource. All right, here's an example from my lab where I was doing a lot of background activities like Nexus reloading and SNMP polling. So I see like instantaneous spikes all along in the show proc CPU history, but my average CPU is only around like 20%. So if you're troubleshooting high CPU issues, try to focus on the average and not the instantaneous spikes. And some customers do this via SNMP, try to poll for a 5-minute average rather than a 5-second average because you get a better graph. And when troubleshooting for high CPU, you can use the show system resources, the show process CPU SART, and basically this sorts from the highest to lowest. Like here, 22% was high in my SNMP. And by far, the most common reason why we get high CPU escalations is SNMPD. And in almost every case I've been involved with, it's due to an overly aggressive NMS application. A lot of applications these days do like what is called as an SNMP bulk get, which is pretty taxing on the switches or any network device because they send like, say, 100 OIDs and expect a response in like, say, 2 seconds or 1 second. And the switch might not be able to respond to hundreds of interfaces in 1 second. And if the application does not get the response back, he's going to send a retry again with another 100 or 200 more, and it kind of goes into the pipeline, right? On the other hand, if you do an SNMP walk, it's more like a transaction oriented. So it sends an SNMP get request, it gets a response, and then sends the get next. So try to use SNMP walk rather than bulk get, and also increasing the timeout on your NMS applications goes a long way. Next, we're going to talk about ETH Analyzer, which is, again, a tool built into Nexus platforms, including the 5K, 6K, which is question. The question is, if I have a COP policy customized, and if I do a Nexus OS upgrade, do the custom CIRs get applied as well, correct? And the answer is yes. Because we do save this in what is called as a PSS, and we, after the upgrade is done, we restore whatever the running config and startup config was. So ETH Analyzer is a tool built into all Nexus platforms to capture control plane traffic. So we can use this for troubleshooting control plane issues like OSPF, spanning tree, IGMP, or you could use to troubleshoot, for example, high CPU. So it's based on the Wireshark project, but it has a Nexus OS front end, so internally it's a Wireshark. And so what the good news about that is you can use your typical Wireshark capture filters and display filters, and also you can use to either write a file to PCAP as a PCAP and open it up using Wireshark application, or you can look for the file, read the contents directly on the switch. And we support ETH analyzer on all three interfaces. Like I said in my CPU section, we have three interfaces, the ETH0, ETH3, and ETH4, so you can do ETH analyzer on all of them. So again, here is my CPU architecture, and here I'm also telling you what kind of traffic goes into which queues. So obviously management 0 is your out-of-band management, and these are our in-band management, and here we have the low priority and the high priority. Again, as the name suggests, the high priority traffic like BPDU, LACP goes to inbound high, and CDP and ICMP and any management traffic goes to ETH3. So here's how you can configure ETH analyzer. Again, the commands are a little different on this platform because we have multiple NIC cards, but you can question mark out of it. So here I do ETH analyzer local interface, and I see my three interfaces I have, which I can use ETH analyzer on. If I pick an interface, I get a bunch of other options, and typical ones which I use at least are like display filters, and perhaps detail, and perhaps write it to a file. So again, I'm going to walk you through some examples as well. So here is an example. I'm trying to capture management 0 traffic, and I'm trying to save it to my switch, and I'm going to also read it on the switch itself. So here is a command for that. So I do ETH analyzer local interface management 0, and write to boot flash, and just give it a name. And by default, we only write 10 packets, but that can be changed. And here is how you can read the contents of the PCAP file. I see like a bunch of SNMP. Does anybody know what this packet, UDP 3200 is? It's not you. Somebody answer. VPC PCAP, good. He's my buddy. He's from Cisco, so of course he knows. But he didn't know yesterday, though. Here's again, I'm using a detail view, and I'm doing for ARP. So I'm doing inbound low, which is where ARP goes to. And I'm doing a display filter ARP. I'm doing a limit capture frames 1, because I just want to see one packet. If you want to see infinite, meaning unlimited, you can just do 0. And I'm doing a detail. As you can see here, I'm seeing like my ARP Ethernet header. I'm also seeing my VLAN. This is one thing I want to focus here on the next couple of slides, because it throws off a lot of people even in Cisco because of the VLAN which we display here. So in my switch, when I did this ETH analyzer, I do not even have VLAN 94 defined. But I still see VLAN 94 in my ETH analyzer, and often I get escalations or emails saying, hey, my CPU is seeing traffic, even though I don't have that VLAN configured on my switch. There's no way the forwarding engines would let this traffic go this far, if that were the case. The reason why we see 94 is because it's an internal VLAN. So on the Nexus 5K, 6K, we always use internal VLANs within the box. So once a packet enters the front panel port, we slap it with an internal VLAN for all communication inside the box, including to the CPU and from the CPU. So anytime you do ETH analyzer, if you see a VLAN, it's an internal VLAN, but the good thing is you can get the mapping. There are multiple ways to get this, but this is by far the easiest way to get the mapping for the entire, all the VLANs on the switch. So, question? The question is, if I were to configure VLAN 94, would the switch be mad? The answer is no, because these are all internal. So for example, if you were to configure 94, it'll just get mapped to another internal VLAN. So in my lab switch, I only had 10 VLANs, but again, this is something, it's not unique, but depending on how many VLANs you have, The mapping is static, so I always try to get this mapping from the customer. Question?
Yeah, within like say the internal VLANs within iOS, it has the block set VLANs, and you can actually look at those. Can you do that the same with this, or make it ascending, descending, or?
Sure. The question is, in iOS boxes, we have this internal VLANs which are reserved, and they can be changed ascending or descending. The answer is we still use internal VLANs which is in the reserved range for other communication. For example, fax traffic, we use VLAN 4042, but this is different. This you cannot change. So again, just keep an eye if you're doing Ethernalyzer. Like I said, even today, because people who are not familiar with internals get confused and they conclude that the traffic made it to the switch with an incorrect VLAN. Obviously, in some cases, I could have had VLAN 94 configured, and they'll basically come to a conclusion that somehow the VLAN got transposed to a wrong VLAN. But if you see anything in Ethernalyzer, the first thing you got to check for is the internal VLAN. CRC errors. How many of you have troubleshot CRC errors on the Nexus 5K in the network? I think a lot of people who have Nexus 5Ks know we are a very low latency switch. So the way we accomplish that is by doing what is called the cut-through switching. So with cut-through switching, the way we troubleshoot CRC errors in a network kind of changes. So here I'm going to use an animation to explain this. So basically here I have an Ethernet packet. Typically this is how Ethernet packet looks like. Obviously you have preamble, but here I'm not showing preamble. But if this packet gets parsed, the first thing which gets parsed is the Ethernet header. And in a cut-through mode, this packet will already be decided to be forwarded because we're not even going to buffer this frame. So at this point, the train has left the station. And if the packet has a bad CRC, we cannot drop it because it's already left through the ingress ASIC, through the fabric, and perhaps on the egress ASIC. So this packet gets switched out on the egress interface with the expectation that some store and forward switch in the path will drop it. But kind of troubleshooting this can get a little tricky if you're not familiar with how to troubleshoot. So I'm going to give you some case studies on how to troubleshoot this kind of a problem. So here, this is something I set up in my lab. So I have 1/6 where I'm getting traffic into the switch, and 1/32 is where my destination is. And I corrupted the frames because I have another cut-through switch, and there's another way to corrupt the frame, which I'm going to cover in the next slide. So I sent a burst of 200,000 frames, and they all were already came in corrupted into 1/6. And since they came in corrupted, I count them as CRC errors, and I also count them as input errors. But this traffic, or these 200,000 frames, would not be dropped on the switch because we're in cut-through mode. We just switch them out, and 1/32 would see them as would not see them as output errors, but it would see as an output unicast packet. And whenever I'm troubleshooting CRC errors, one thing I always check for is the hardware counters and see if they are either stomped or non-stomped. So, in a high level, stomped means like some cut-through device in the network took a good packet and made it into a bad packet. Again, there are some conditions where we can have that operation, but we're going to cover that in the next couple of slides. But in this case, I had another Nexus 5K connected to 1/6, and he took a good packet and made it into a bad CRC packet, so that's why it's counted as stomped. If it were corrupted on the fly, meaning if something was wrong on the physical layer, the not stomped increment would increment. So in this case, these 200,000 packets would have left on 1/32 as a frame error. So in older code, we used to also count these as egress CRCs or output errors, but in the newer code, we do not because we use that output error field for another drop counter between a parent and an N5 effects. I'm trying to get that changed, but in today's shipping code, the ingress CRC errors are not counted as output errors, but they are counted as frame errors in the hardware counters. So here is the stomping operation I was talking about, where a switch can take a good packet and make it into a bad packet. So here, again, I have the same interfaces, 1/6 and 1/32. My switch is configured for 1500 bytes MTU, as you can see here. Now I'm getting 9,000 byte frames. Again, since we are in cut-through mode, we cannot even do a length check or an MTU check on this packet, so we just have to truncate this packet. But we do also count this as an interrupt, as an MTU violation on the ingress ASIC. And we just truncate the packet and switch the 1,500 bytes, but we mark it with a bad CRC. So this is what is the stomping operation. Stomping operation is we took a good packet and we made it into a bad packet. So again, same thing applies on egress. We only send 1,500 byte packets, and we count them as frame errors. And we also fire up one more interrupt because on the egress, we marked it as a stomped CRC. Again, these commands will be useful when you're troubleshooting CRC errors in your network, and you have to figure out whether they're coming in stomped or they're getting corrupted over your physical layer issues. Here is a summary. Again, CRC errors can be seen for three reasons. One, you either have really a bad physical layer, meaning you can have a bad SFP, bad cable, or a bad MAC. Or it could be stomping, like meaning you have another cut-through switch connected downstream, and he took a good packet and made it into a bad packet. And the last thing is we stomped it ourselves, like meaning we got a good packet and stomped it ourselves. So it's not that hard, but it needs some logic to troubleshoot CRC errors. Typically, I start off at the first store and forward switch. Say you have a Nexus 7K, which has been counting CRC errors. So I start going down south from there, like meaning go to the next hop device. It typically will be a 5K or 6K. And then look for any RX CRC errors on that particular 5K. And if you see RX CRC errors, then you need to find whether they are stomped or non-stomped. And depending on that, you need to see if it's a physical layer issue or if the switch himself is making it into a bad packet. So if the switch himself is making it into a bad packet, you'll have to start looking at the interrupt counters and figure out why it's happening. Any questions? And in the last resort, you can do store and forward mode. Personally, I do not recommend this because it requires a reload, and also you lose the cut-through latency, which we get with cut-through switching. Question is this hardware Ethernet store and forward per interface, or is it global? The answer is it's global. You just configure the config command, and it applies for all interfaces. All right, now let's talk about some interesting stuff, forwarding. I'm going to be spending about next 30, 40 minutes on forwarding because I'll be covering L2 forwarding for unicast, multicast, and L3 again unicast and multicast. We have like multiple forwarding tables on the Nexus 5K, 6K, but these are our three key tables. For layer 2 forwarding at least, we're going to focus more on the host table. The host table as a whole is 256K. By default, it's divided by 2, like meaning half of it is for MAC address and half it is for your /32 routes, which is your ARP table or any other /32s. But this is a sliding scale. We're going to talk about that as well. And we also have, for layer 3 stuff, we have longest prefix match route, which is 32,000. And we have 64,000 for multicast, which we're going to talk about in the multicast section. So for this section, we're going to focus more on the host table. So again, I think I've shown you this diagram quite a few times. Like architecture-wise, like we have the fabric, we have multiple ASICs, and we have the CPU ASIC as well. And on the CPU, we have like multiple processes running. As far as the layer 2 MAC address learning, we have, these are the important processes here, or the components. We have the STM table, which is our station table manager, which is the MAC address table in hardware. And then we have the FWM process, which is a process on the CPU which manages the STM table in addition to many other things. And he also is responsible for MAC address synchronization between the different port controllers and MAC aging process, deletions, and additions if they were learned through VPC or VXLAN. So let's see how MAC learning works at a very high level. For this argument's sake, let's say Mac B is already learned on the system, like UPC has this, CPU has this, and UPC1 has this MAC address B learned. Now let's say Mac A, a server with Mac A comes online and sends the traffic towards server with Mac B. First thing we have to check on the ingress ASIC is for a spanning tree state, because if VLAN is not allowed or spanning tree is blocking, we cannot forward this traffic. So assuming spanning tree state is forwarding, so the ingress UPC at this point learns the MAC address without even any involvement from the CPU. So since we already know MAC-B and every UPC has MAC-B in its STM table, this packet gets switched through the fabric, at which point the egress UPC also learns the MAC. So at this point, with this flow completed, we have this MAC-A learned on UPC1 and UPC-N in case it could be UPC4 or 32, depending on which LEM it is. So at the same time, the ingress UPC also interrupts the CPU because the other ASICs on the CPU has to learn this MAC address. So when this happens, the CPU then programs every other UPC with this MAC address. So the point I'm trying to make is MAC address learning happens at line rate in hardware with no involvement from the CPU, and the CPU is only responsible for updating other STM tables and the MAC operations like aging and deletions and additions if they're coming from VPC or VXLAN. Any questions? All right, let's use a case study. I'm going to be using for case studies for every forwarding section or almost every section going forward. So I'm going to be using this topology in my lab I have, where I have like 3 devices, all in VLAN 10, and I'm going to be using some commands to show you how to check for programming both in software and hardware for layer 2 forwarding to work fine. So typical symptoms when things are not working fine is you might have like unicast flooding, traffic getting black holed, and problems like that. So this is our goal here. We'll verify programming for L2 forwarding. First things first, I need to know which ASIC my ports are on. Again, this is a common command which you can use all the time. So you can use the show hardware internal bigserve all ports. So I have 1/1 on ASIC 1, 14 on ASIC 2, 28 on ASIC 3. So I'm going to check for my typical spanning tree and MAC address table, which, again, it's nothing fancy. You use this command across multiple Catalyst switches, I'm sure, or even Nexus switches. So my spanning tree is forwarding for all the VLANs, and my MAC address is learned fine as far as the CPU is concerned. So now I check for my entries in hardware. This is how I check for my spanning tree. Even though the forwarding manager is processed on the CPU, but he's responsible for making sure the spanning tree is forwarding in hardware. So here I see like 1/1, 14 and 28 are all forwarding, so it's all good. And this is how I check for my MAC address table in hardware ASICs. So ASIC 0 is CPU ASIC, ASIC 1 is my ASIC which has Ethernet 1/1, and 2 has Ethernet 1/14. Again, this table should be synchronized across all the UPCs in the platform. If it's not, you'll potentially have some forwarding issues. Because say if MAC is not learned on ASIC 2, if the traffic were to hit the port, we're not going to go to the CPU. We're going to just look for what our hardware entries are, and if it's not there, it's not there, and traffic cannot get forwarded or it might get flooded. And this by far is probably one of the most useful commands we have on the platform, especially when you're troubleshooting some MAC issues like MACs getting deleted, MACs getting not synchronized. The show platform FWM info MAC and the VLAN. This is again like a FSM or the event history command which I talked about initially. So this is the event history for a particular MAC address. And we keep the last 35 operations, which is pretty good. So here, for example, it gives me like the history on what happened to this MAC. It says was MAC created, at what time, how it was learned. And since my switch is also part of VPC, it's saying it's sent to VPC peer on a local learn. So if in case it was deleted, it'll give you like why the MAC address got deleted. Perhaps it got aged out, perhaps it was a spanning tree topology change, and things of those nature. So very useful command when you're troubleshooting Mac issues. Next, we're going to talk about troubleshooting for drops and how we can troubleshoot drops. Again, this comes from one of the cases I was involved in recently, and I'm going to use this as a case study because I had to reproduce this in my lab. To check for any drops, as far as forwarding manager is concerned, like this is the command we use, the show platform fwm info piff. If this is a port channel, use lif, which is logical interface. So since this is a physical interface, I'm checking for piff. So I'm first checking for ASIC. I think I already know that it's an ASIC 1, but then I grab for drops. I see my drops are incrementing. Many people, if they see drops here, they just conclude saying, oh, I found my problem. My switch is dropping packet, so we need to do something about it. A lot of people in Cisco do that too, but my answer to them is always is no. Many of these drops could be expected because of the configuration, or for example, if you had an access list here, dropping the traffic or configured to drop the traffic, we'll count them as a drop. Or say, if 1/1 was connected to a device with more number of VLANs, like meaning it had like more VLANs than we are configured for, and if you get traffic with VLAN IDs which we are not configured for, they get dropped. So there are many valid reasons why these drops can be seen, but whenever I see a drop, I start looking further. Question? The question is, are these drops input discards in queuing? Is that what you're trying to ask? The answer is no, these are forwarding drops, because first we have to make a decision on whether to forward the frame, only then they go to the queues and the discards come next. Like I said, drops can be seen for various expected reasons, but whenever I see a drop here, I always look into this more. So the next thing we need to check for is ASIC errors. So I know that 1/1 is on ASIC 1, so then I check for ASIC errors for ASIC 1. Again, this came from a customer escalation I was involved with, so this was a new experience for me. So I saw drop IDS code 01. So I'd never seen drop IDS code 01 until I got pulled into this escalation. So then I checked with some engineering and also looked through source code, and I found some reasons why they were getting dropped, but I had to look a little more further to see if the customer traffic flow which was getting dropped was indeed due to this PIF drops. So the good thing about this platform is we have this feature where we can redirect FWM drops or forwarding drops to the CPU. So I use this almost on a regular basis whenever I get involved with any FWM forwarding manager drop scenarios. And how you can do this is basically enable this debug command, debug platform, FWM packet drop, redirect. And this IDS code, again, you don't have to remember this code. If you do a question mark at this point, you get a very exhaustive list of drop codes. And here I selected IDS code because my ASIC error said IDS drop condition. So then you select the ASIC ID, and then basically fire up your ethanalyzer and specify a filter, because I knew that my server on 1/1, again, this was from my lab, so I knew the IP address was 10.38, and the destination was, I didn't bother about destination. Destination is here. So that I did a detail. So this drop traffic was redirected to the CPU at this point. So then we found that in this particular packet, the IPv4 checksum was incorrect. Typically, a layer 2 switch does not care for IPv4 checksum errors, but the Nexus 5K, 6K does, because anyway, this packet would have been dropped somewhere else. So we drop it. So anyway, in this case, the root cause was there was an application issue, so customer had to fix it. But as you can see, this redirect feature can be very useful when troubleshooting any drops due to FWM. Any questions? Host table exhaustion. I think my first forwarding slide said we have 256K host table size on the N5Ks, or 5600 and 6000, which is pretty exhaustive. I don't think any other Cisco switch has this many MAC addresses capacity. in the event you have a situation where you exceed this capacity, again, out of the 256K, default is half and half, like mean we reserve half for MAC address and half for /32 routes. If you ever run into that condition, you'll see a message like this, and this is how you can check for your MAC addresses being used. So here, even though it's 128K in capacity, but we have some reserved entries, so the max you can have is 123K, which is pretty large. So hopefully you guys never run into this capacity issue, but if you do, the good thing is we have this template-based change which we can do for the host table. So by default, it's 128K and 128K, but if you have a situation where your layer 2 MAC address scale is humongous, you can perhaps change this to 224K for STM and allocate 32K for host routes. Again, this is not a common problem, but if you ever have a problem like this, you can, basically it's a sliding, the host table is a sliding scale. And these are some of the templates you can use, and it requires a reload, and these are some of the templates you can use. Questions? All right, next question. Station table manager. It's a MAC address table. And question is, what is STM? STM is a station table manager, and it's basically the MAC address in hardware. Correct. The host route table. It's HRT. Any other questions? All right, let's move on. So now I'm going to cover some section about L2 multicast forwarding. So on the Nexus, previous generation Nexus 5Ks, we used to do what is called MAC-based forwarding, meaning we used to program every interface with a multicast MAC address associated with the multicast IP address. But in the Nexus 5606 case, we do what is called IP-based forwarding. So if you guys are familiar with multicast, if you do MAC-based forwarding, we have this problem with overlapping addresses. So we do not have that concern here anymore. So by default, for layer 2 multicast, we support 4,000 IGMP snooping groups. This can be increased to 16,000, but I just got confirmation from engineering because they were on my one of my dry runs. They said this is not really recommended, meaning it's not tested enough. So, but we still have this capacity. But if you ever have more than 4,000, you can change it. It does not require a reload, but the switch is not optimized for 16,000 IGMP groups. So it's optimized for up to 4,000. So that's why we are default is 4,000. So again, I'm going to use a case study to show how to check for multicast forwarding, both data plane and control plane, and how to troubleshoot this problem. So in my lab, I have a setup where I have a server which is sending membership reports. It's on Ethernet 1/28, and given that I have an IGMP courier and I have it on my port channel, and basically we'll use this case study to check for programming. Some basic commands, make sure IGMP snooping is enabled. Actually, it's enabled by default, so you don't have to do anything there. But you have to make sure you have a courier present. And I have my courier on port channel 672, which is my N7K. Then I have my active interfaces, which is 1/28, and a bunch of other interfaces. And I also have my mRouter port, which is port channel 672, which is my N7K. And port channel 572 happens to be a peer link. It's always part of my mRouter table or port. So for IGMP control plane troubleshooting, we have a lot of options on this switch, or most Nexus platforms for that matter. So here, let's start off with no IGMP membership report received. So I'm going to use Ethanalyzer as my first tool. So I use my Ethanalyzer and use IGMP as a filter. And once my membership report hits the switch, I see an entry there. So at this point, we should start programming the interface for the group. So and we also have our best friend, the event histories. Again, you don't have to remember this command. You can use the show CLI list. So here I see that at the same time my Ethanalyzer saw the membership report, my event history also sees it. And also this is very useful when you're troubleshooting IGMP in a VPC setup. And now I have my membership report received, and my interface is programmed for 238.1.1.1. For data plane, we forward traffic in hardware, meaning we don't rely on CPU to forward multicast traffic or unicast or any traffic for that matter. So that means that certain hardware has to get programmed by the software or the CPU. Since we are talking about layer 2 multicast, our multicast pointer is what gets programmed for any particular groups, and that kind of gets trickled down from the IGMP level or the supervisor level all the way to hardware, and these are the various components involved in between, so it's different levels of abstraction, and I'm going to walk through each level to see how to troubleshoot at each level. So at the IGMP level, again, it's the show IP IGMP snooping command. So basically, I see that IP IGMP snooping groups VLAN 10. I have my 1/28 program, and everything is good. At my multicast RIP level, I do my show L2 mroute command because we do IP-based multicast forwarding here. So I'm checking for my L2 mroute. And at my multicast fib level, which is actually on the hardware, on the UPC or the port controller, I get my multicast tag, which is important for us to get the outgoing interface list. So I get my multicast tag, which is 94. So now with this information, I can find my flood reference or the flood index, which is my multicast index, which is 219. And again, there are multiple commands you can use to check for which interfaces are programmed, but I'm going to use this command more. So I'm going to use my show platform FWM info OIFL, which is outgoing interface list 219, and I see my 3 interfaces which are programmed. My mroute reports are always going to be there, and my 1/28 is also there. So again, these are some of the basic troubleshooting you can do to check for any L2 forwarding issues. Obviously, if you see any discrepancies here at this point, you might have to involve Cisco TAC folks. All right, next we're going to talk about layer 3 unicast forwarding. Again, there are major differences between this platform and the previous generation Nexus 5Ks when it comes to layer 3. On the previous generation Nexus 5Ks, we had what is known as the router module, and we used to use the router on a stick model. But here, layer 3 is kind of built into the pipeline, so we can forward packets much efficiently because we don't do the router on a stick. So similar to the previous generation, we still require licenses to do layer 3. We have the base license and the enterprise license. So the base license is good enough to do most IGPs, but if you have to do BGP or some BFD, you'll require the enterprise service license. So again, I want to focus a little bit here. Non-deceptive ISC is not possible if you install layer 3 license. I've seen some customers install layer 3 license without knowing this, even though they're not doing layer 3 on the box. So unless you're doing layer 3 on this platform, please do not install any layer 3 license because you lose the capability to do non-deceptive ISSU. And another thing which is unique to this platform is we have something called as a MyIPR table, which is essentially a TCAM which is 512 entries long. It has a list of all MAC addresses which the switch can route for. If you guys are familiar with Nexus 7K, I think they call it the gateway table, and they have a G flag. But in 5K, 6K world, it's the MyIPR table. So the way the L3 lookup works is if it's hit against a MyIPR table, it goes to the forwarding pipeline is layer 3. If it's not, they go to the L2 pipeline, which is the STM table. So again, here's a little graphical representation. So this MyIPR table is 512 entries. Why I'm telling 512 is because if you have HSRP with 500 plus VLANs, you might run into limitation here. We can't use unique groups. You'll have to reuse groups. Hopefully, you're not routing between 500 VLANs, but that's the limitation of this table size. So if it's a hit against this, the next table which gets matched is the default 128K host route table. And again, that can be changed if needed, meaning it can be increased or decreased. If there's not a hit against the HRT table, the next table which gets matched is the longest prefix match table. Again, this is common sense routing, longest prefix match routing. Again, I'll use this as a case study to check for my hardware programming and software programming in hardware and software. So here I have a prefix 50.157, And I have a server with 10.138 in VLAN 10, and have routing configured on this switch, and I'm running my prefix via 2 equal cost ECMP OSPF routes. So that's my goal here, to check for latency routing information in hardware and software. So first things first, I check some basic checks. I check for my HSRP, whether it's active, my interface VLAN is up, this is my MAC address, and I check for my HSRP MAC address, and then I check for my HSRP information in terms of layer 3 and FWM, so it's all good. And then I check my IPR table. So here I have my MAC address, which is my HSRP MAC, and my SVI MAC as well. So at this point, if this switch were to get any traffic with the destination MAC of SVI or the HSRP, the switch can route. So again, just like we saw for layer 2 multicast, same concepts apply. We forward traffic in hardware. So when the rubber hits the road, this is where we have to check for our programming. And typically it's some index or a pointer. So that pointer or index gets programmed all the way from our client protocols, and there are multiple levels of abstraction between the client protocols and the forwarding ASICs. And when you have any forwarding issues, you will have to check for programming at each level and make sure that they're identical to the previous level, the previous stage. And I'm going to walk you through how to do this for unicast. So at the URIB level, it's typically your show IP routes and show IP ARPs for unicast routing. So here I'm doing a show IP route for my prefix. I can see that it's learned via 1/3 and 1/4, and I know my next stops. So next I check for my ARP table and make sure that the ARP is resolved. So at this point, my URIB looks good. UFTM is stateless for unicast. It exists, but there's not a way to check for the state. But his responsibility is to program all the port controllers. So then I check for my UFIB entries. Again, the commands on the UFIB are typically your show forwarding routes. So here, this should be a replica of your show IP route, and the show forwarding adjacency should be what should be in agreement with your IP ARP table. So here, my next stops are good, my next stop interfaces are good, and my forwarding adjacency, my ARP table and this MAC address should be in agreement. Then I get my adjacency index. Like I said, this is what matters because this index is what gets hit in hardware when the traffic gets routed. So for my prefix, the adjacency index is 0xe. Then I can find out what the rewrite information is for my adjacency index. And in this case, for 0xe, it is this particular MAC address and this particular bridge domain, which is the internal VLAN. And this MAC address belongs to the next stop or the next stop MAC address for the ARP table. Again, this does not make sense if you just look it on a slide, but if you're having forwarding issues, you'll have to go back and check for your entries at each level. And typically, when you have a problem like this, it is time to call Cisco. Any questions? All right, we have 32,000 capacity for our longest prefix match table, but it's still a finite number. So if you were to exceed that number, this was more of a problem with the previous generation 5 case because we only supported 8,000 LPM table. But if you were to exceed the table, you'll see a message like this, and this is how you can look for your route information in hardware and how many entries are being used. All right, next we're going to look at L3 multicast forwarding, similar to what we did for unicast. So here I have a source in VLAN 10, and I have a receiver in VLAN 10, and I'm multicast routing between 10 and 20. So server in VLAN 10 is sending traffic to this group, and receiver in VLAN 20 is IGM sending membership reports to that particular group. And it's given that I have all this configured because you need those configurations for multicast routing to work. So this is the task. We'll verify the state and programming for the group. Again, similar to what we checked in unicast routing. So we have, again, multiple levels of abstraction before the hardware gets programmed. So we're going to quickly walk through how to check for entries at each level. And for layer 3 multicast expansion table is our key value which gets hit. And based on that, we get our flood reference. So the mrib level, we use a typical show IP mroute command. And here I have my S, G, which is my incoming interface, and my outgoing interface list is VLAN 20. So that's good. So then, unlike unicast, here we have a state in MFDM, which is responsible for programming all the MFIPs on line cards or UPCs. So here I check using the show forwarding distribution command. And here also I see my outgoing interface list is good and my S, G is present. So one thing which gets asked a lot in TAC is, or some people get confused, is this does not really update in real time. So this is basically a state getting updated. So you will not see this packet increment, this counts go up a lot. So some people just come to a conclusion that my switch is not doing multicast routing. There are ways to enable this debug using a debug, but by default, they're not enabled. So do not just rely on this received packet count and come to a conclusion that multicast routing is not working. For the MFIB level, again, we can use the show forwarding IP multicast route group command. Again, you have to make sure that this is in agreement with MFDM and MRIP. So in this case, it is. So basically, I have an S, G with outgoing interface list VLAN 20. And now I'm going to get my multicast expansion table pointer, which is the important thing for hardware from MFIB. So based on this, I can find my flood reference, which is 239. So then I use my typical FWM command for outgoing interface list, and here I see my 1/28 and 4-channel 572, which is peer-link, as my outgoing interface list. Any questions on any of the forwarding sections? All right, buffering and queuing is another area where we have major improvements when it comes to 5600 and 6000 compared to the previous generation platforms. So I'm going to spend some time here as well. So per UPC, we have 25 meg buffer on the Nexus 6000s and 5600. Out of the 25 meg, 16 meg is on the ingress pipeline, and 9 meg is on the egress pipeline. So and again, we have like different buffer carvings, but at a high level, like unicast traffic can be buffered both on ingress and egress, and multicast traffic gets buffered only on egress. And these are our default. We use like what is called the flexible buffer management, like meaning we have a dedicated buffer, and also we have the shared buffer. So dedicated buffer is typically good for your reliable and predictable performance. Shared buffer is good for burst absorption. So we have a combination of both, which is the best possible thing. So in the event you have to change this, you can change this 100 KB to a max of 1 meg using a QoS policy, but personally I never had to do it because the default with the shared buffer works just fine. Again, this is on the ingress. On egress, for unicast, we have 363 KB for 10 gig port and a little more for 40 gig port. But on multicast side is where we have most of our buffers on the egress side. So on a 10 gig port, we have 4.3 meg. Again, this is per ASIC. And for a 40 gig port, we have 6 MB on egress. How many people do multicast in the network? Okay, I do see a lot of people. So we have a lot of multicast heavy customers ask for this feature. So we're coming out with this feature in the 7.2 release. So with the 7.2 release, we can reduce this unicast because we have plenty of buffers on ingress side for unicast. So we're going to take up, I think this drops like about 100 KB. So this goes to about 6.6 KB or MB, I'm sorry. And this goes to about 8 meg with this command, which is coming in 7.2, which is expected any day now. So if you do hardware multicast buffer tune, this number becomes 2 MB more for 10 gig port, and this becomes about close to 8 meg. Question?
When you put that command in, does that apply to every porting ASIC, or can you apply it to specific ASICs?
Question is, when you apply this command, is it for particular ASIC or is it for all ASICs? The answer is, this is a global command, so it gets applied to all ASICs. But since you bring up that question, I have another interesting thing to share. So even though you have 4.3 MB or 6.3 MB with this command, this is just one buffer pool. So we have like 6 QoS groups in the platform. So this in reality is, you have to divide this by 6. Again, that can be changed. I'm going to talk about that in the multicast queuing troubleshooting section. But yeah, you bring up a good point. Thank you. So these are our queuing implications. Like when you're troubleshooting something, for unicast traffic, if there's a congestion on egress, the drops happen on ingress, because that's where most of our buffering is. And for multicast traffic, if there is a congestion, the drops occur on egress because there's no buffer on ingress for multicast. I'm going to use this case study again to troubleshoot queuing issues. So say you have a network, everything is working fine, and all of a sudden you start getting complaints about performance problems. So in this setup, I have server A sending traffic to server C. Everything works fine for a few months, few years. Then I start seeing performance problems, and I start seeing discards. I'll show you how to troubleshoot this. All right, to begin with, I have server A sending line rate bursts to server C, like meaning 100,000 bursts, no drops, everything is fine. So I have like 100,000 packets received on 1/1, 100,000 packets sent to 1/1, and no drops. This is when we start seeing problems typically in networks, like say another server comes online, server B, and he also starts sending line rate traffic to server C. No amount of buffering can buffer 2 line rate port traffic to one 10 gig port or same speed port, so we have to drop traffic at that point. So now we start seeing drops on ingress on 1/1 and 1/14 because it's unicast. So how you can check for these drops? You can do the show queuing command. Also, we export those discards to show interface. So here, as you can see, about 41,000 packets dropped on both ETH11 and 114 when I sent line rate simultaneous bursts to 1/28. Any questions? Typical reasons to see ingress discards. One scenario is the one which I just described, where you have multiple interfaces bursting to a single 10 gig interface or a same speed interface. The other common scenario is speed mismatch. You might have traffic coming in on a 40 gig or 100 gig from your core, and you have a 1 gig or a 10 gig port connected on the FEX. And again, no amount of buffering is possible to buffer that speed mismatch. Then ether channel hash collision. You might have a case where you have multiple interfaces on the switch trying to pick one member of a port channel. Lastly, microbursts. Like these days, servers are very bursty and applications are very bursty. So you could have a scenario where they're sending number of packets in a very short interval of time. But the good thing about the Nexus 5606 case is we have a lot of these data analytics which can be useful to troubleshoot problems like these. And we have an entire session on these. Like I think I have it in my reference slide. So we can do like microburst monitoring. If you're seeing ingress discards, we can just span those drops or year span those drops and see what those drop packet is. It's extremely useful if you're trying to profile some performance issues and want to see why a particular application is getting dropped. You can also do latency monitoring. If you're seeing latency issues in the switch, you can check for latency between port to port. And you can also check for buffer usage. Remember I said we have 25 meg buffers. We can see how much of the buffers are being used. And lastly, but the most important thing, which is a big boon for you all and Cisco TAC folks, is the capability to identify the egress congested interface. So in my lab, I knew 1/28 was congested because I was artificially congesting it. But in a production network, you cannot, right? So, but I know that 1/1, 1/14 were seeing discards. So I can use the show platform QD command for the ASIC and try to see where those drops were destined to. So if I do this command on ASIC 1, it tells me that all my discards on ASIC 1 were for Ethernet 1/28. So at this point, I know that Ethernet 1/28 is congested, but now I have to figure out who else is sending traffic to 1/28. So I go on to my next ASIC where I'm seeing ingress discards, which is 1/14, which happens to be on ASIC 2. So I do the same command, and I see 1/28 here as well. So at this point, I think anybody can say that 1/28 is congested, and obviously you're tasked to figure out why it's congested, but at least the network switch can tell you which egress is congested. And you can also do this command on the egress ASIC or the egress port, and it will give you which ASICs the traffic was coming from, which were dropped. So this is very useful and powerful when you're troubleshooting discards. In the past, we used to always struggle to identify which egress was congested, but now with the 5600s and 6000s, you can identify the congested interface. Same thing for multicast queuing, but remember for multicast, the drops happen on egress. So here I'm sending 500K line rate bursts from 2 different 10 gig ports to one 10 gig port, and I'm going to expect some drops. So here I start seeing output discards on 1/8. No drops on ingress, and I see all my 500,000 packets counted for. And I think I already covered this. We have the 7.2 feature coming. This will increase your egress multicast buffer by about 2 MB per ASIC. But I think this is also a very useful command which we have in 7.1. If you're not doing any QoS, meaning if you don't have any custom QoS, there's no point in using up that buffer for queues which are not being used. So this basically enables sharing of all the buffers between the 6 queues, and one default QoS group can use that buffer. Any questions? The question is, if I have marked traffic, should I not use this command? The answer is you can still use it, because you might still have a case where other queues are not being used, right? You might have like 6 QoS groups carved up, but what are the odds of all 6 QoS groups bursting at the same time? So you could still use this command. But this command is available in 7.1. There are debug commands which you can use in the older code, which obviously does not survive a reload, but it is configurable in 7.1 and later. The question is, this is only tuning the egress buffer. The answer is correct. It's basically, the ask was to see even if we can take buffers from ingress. Architecturally, engineering came back and said it's not possible. So we're doing this just on the egress side of the buffer. Any other questions? Question? I couldn't see you, sorry. Say it again? The question is, do we do egress or ingress multicast replication on this platform? The answer is it's fabric-based and egress replication. For the most part, it's egress. Say you have like multicast traffic which needs to go to like multiple port controllers. So the fabric sends one copy to each port controller, and if there are multiple receivers on each port controller, we do egress replication. Any other questions? What was the question again? Any latency we should be worried about by increasing the buffer? I would say it's not, because if anything, we are giving more buffers, right? For unicast, it's never a problem because we have very good accounting between egress buffers and ingress buffers. So we have plenty of buffers on ingress for unicast. Multicast is where we had, again, we still have a lot of buffers, but we are just increasing the availability even more.
Say I am tagging traffic and I do burst
Mm-hmm.
part at the threshold. What's one of the replications, or what's one of the implications I like to use that?
So you do have, question is, you do have queues configured, and what are the, if all your queues are bursting, what are the implications? You could still see some drops at that point. Again, from my experience, like 9 out of 10 customers do not have any QoS configured. So for those customers, this makes total sense because otherwise you're only getting 1/6 of the buffers available for multicast. If you do not have any QoS and if you're doing multicast, just enable this command because it doesn't make sense to have 1/5 of the buffers not being used at all. Question? No, actually, I'm sorry. The question is, are these commands changing between versions? Actually, these two are totally different commands. So this command essentially increases the total available multicast buffer in the pool by about 2 meg because we take some from unicast because we have plenty of unicast buffers on ingress. So this is a totally this does a totally different thing. Basically, this does what is called as we have like multiple hardware queues in the platform, and we allocate buffers to every queue, whether you use it or not. So if you're not using those custom queues or QoS groups, this makes that all the buffers available to one QoS group, which is typically your QoS group 0. Well, the question is, you have another receiver on 1/9?
Yep, that's on the same ASIC as 1/8.
Okay.
So the real question is the drop. Is it happening on the port or is it happening at the buffer?
It's happening at the question is the drop happening at the port level or it's happening at the buffer level? The multicast buffers is not per port, it's per ASIC, so it's at the buffer level. It's kind of hard to do that because how are you going to spread out? Because you might have multicast groups coming in and going out dynamically, right? So how do you do that? It's kind of hard. Again, with these commands, again, this command is not available today, but this is available today with the debug command. It's made a lot of difference for customers. And since we got such good feedback, so we're making this configurable, or we made this configurable in 7.1. So if you are doing multicast, and especially with no custom QoS, this is something which you definitely need for better multicast performance. All right, so I have one more section. I saved the best for the last, ELAM. How many of you have used ELAM on other platforms like Nexus 7K, Catalyst? Not Cisco folks. All right, ELAM stands for Embedded Logic Analyzer. Again, this has been one of the longest asks from TAC and field to the business unit. So I was involved with that a lot, so I'm very passionate about ELAM. So it's a very useful feature when you're troubleshooting packet flow issues. Like for example, say you have a very complex network and you have to figure out whether a packet made it into the network, because you can always use span. Span is kind of very hard because somebody has to go to the data center and many ports are 10 gig or 40 gig and you might not have a 1 gig port. So this is where ELAM comes into picture. So ELAM, as the name says, it's Embedded Logic Analyzer. We started supporting this in 5600 and 6000 starting 7.x. It's not supported in the previous generation platforms. So it's useful for scenarios where you want to see if a packet made it into the switch and what happened to the packet in terms of a forwarding decision, what the switch did with this packet. And if the packet made it into the switch, if the packet left the egress, at that point, perhaps you need to move your troubleshooting to somewhere else. So it's very useful to reduce your time of troubleshooting and at least focus on the right device in a network where you should be focusing. And there's no impact of configuring ELAM because it's run as a hardware in parallel to our lookup process. but it cannot be used for troubleshooting performance problems because ELAM only captures the first packet. So if you're having, like, say, 20% packet loss, ELAM is not your tool. Perhaps SPAN is your tool for that. Initially, it was meant to be used for TAC and development, but as we get in a WebEx with customer and TAC and development or escalation like myself, we start using it, customers get interested and start want to learn about it. So there's not a very lot of documentation on this ELAM tool, so that's why I'm hoping this will be useful for you guys. So again, I'm using this as my case study. I have a server sending ICMP traffic to server B, and I'm going to use ELAM to basically track this ICMP packets. One beautiful thing about Nexus 5600 and 6K is you don't have to really know about which ASICs, but it's always good to be very specific. So I always configure ELAM based on a specific ASIC, but you don't have to. You can do the ELAM across the chassis and all ASICs. So for example, here I'm doing an ELAM slot 1. You could do slot all. And I'm doing ASIC Bixer instance 1. If you don't want to care about ASIC, you can do instance all. So at that point, the ELAM would get triggered on, or at least get configured on all ASICs, but the match would be only on ASIC which it got hit. But personally, I still like to do, because I'm used to configuring slot and ASICs, I use this, but if you want, you can still use slot all and ASIC all as well. So here again, we have like multiple options. I'm doing a trigger, lookup, ingress, and video question mark. I have options for ARP, CE, fiber channel. I've never really used it for fiber channel, but I've used it for the other three, but I'm sure it works for fiber channel as well, and IPv4. Second, ARP is obviously if you're troubleshooting ARP issues. CE is for non-IP traffic, like CDP, spanning tree, LLDP, LACP, those kind of things. IPv4 is IP traffic. And since I'm trying to capture my ELAM for ICMP, so I'm doing a trigger lookup, ingress, IPv4, and I know my source IP and my destination IP. And at that point, I can do my start capture. So ELAM is configured at this point. So now if we do a show capture lookup, unless there's a packet which made it to the switch, you'll see nothing captured. So now if I send my ICMP packet, I'll see my ELAM results. So if I do a show capture lookup, I see my ELAM packet. Again, another good thing about ELAM on this platform is it does all the decoding for you. Like in other platforms, you have to get some indexes and do some more decoding. But on the Nexus 6K or 5600, the switch does it for you. In this case, it is telling me that the ingress interface was Ethernet 1/1, and it's not a port channel. And you can also look at some of the fields in the packet. So here I can see my source address, destination MAC address, source IP, destination IP, my L3 protocol, my TTL. There's a lot of things which you can look at ELAM. So at this point, you can see that the packet made it into the switch. And now we can also see what the switch decision was with this packet. So if I do a show capture RS, which is my result vector, the switch will tell you my decision is to forward this packet out on interface Ethernet 1/14. So again, if there was any rewrite information or rewrite which happened to be done, you will see a different source MAC, which is typically your switch MAC, but in this case, it was all layer 2. So again, this was on the ingress side. You can also do on the egress side, because something can happen between your ingress and egress, so you can also do egress ELAM. So here I select, instead of ingress, I select my egress as my trigger. Again, the trigger command is the same. Otherwise, I'm doing by source IP and the destination IP. If I start my capture and send a packet, I see my packet here. Question? No, question is, can you have multiple triggers? You cannot. But you can have multiple variables in the trigger. Like here I have like source IP, destination IP. You can be more specific. You can add a port number, UDP port number. The question is, can you do both ingress and egress? The answer is no, you have to do one at a time. It always makes sense to do one at a time too, because you have to first make sure the packet made it into the switch and what the decision was, and see what happened on the egress. Again, very powerful when you're troubleshooting network issues, and it saves us a lot of time when troubleshooting issues. And you can use this for multicast too. If you're using for multicast, if you were to do like a show capture RS, typically you would get your, maybe go by RS. Here you see like either a multicast index for layer 2. If it's a layer 3, you get your multicast expansion table pointer, and then you can use your multicast commands, which we went through in multicast forwarding section, to see how the forwarding looks like. Any questions? All right, that concludes our session. Again, these were our session goals. Basically, learn about some platform troubleshooting issues and the common issues, and also learn about some of the tools we have in the Nexus 5K and 6K. I hope we accomplished them. Again, thanks for attending this session, and hope you enjoy your rest of your CiscoLive and this customer appreciation party. Thank you.